Hello everybody to our next stream to Unreal Engine 4 and today we will talk about materials and shaders in Unreal Engine, probably the most important part of any artist workflow in Unreal Engine. If you can hear me okay and we have no sounds problem, we can begin. Just let me know in a chat. Uh, yeah, and we will start in a minute. Yan Chao, hello. We have 3 viewers right now, so we at least one Erasmus student is missing. Of course, if you have any questions, you can ask them in a chat. I will look up it once in a while, and as always, this stream will be available for you to watch after it ends. So, hi Luca, hi Danim. It's nice that you're all here. So let's start. And first of all, let's talk about what is a shader and what is material. Very quick, because we of course were talking a little bit about it on our first classes with Unreal Engine in school. And materials are actually everything which applied to our meshes. So if you can see here, this chair and this table all has different materials. For example, this metal part and this yellow part is all controlled by a material. This glass, for example, is also a material, as this metal stand. And as you can already see, the material is something which actually adds a material to our objects. So it defines from what material this object is created. So this is metal, this is, I guess it's a kind of plastic, this is some kind of rubber, I guess, or something like this. So the materials define the physical properties of our objects. And shaders are actually the math, the pure code and programming which teaches our materials to behave like a physical objects. Like if we see metal, we expect it to reflect some stuff, to shine in the light like this. If it's glass, we expect it to reflect the environment as glass, and also to refract the environment behind it. So we always expect some physical interaction with our materials, and the shaders are pieces of code which actually allows our materials to behave like they behave as we can see them. This sky, for example, is also a material which is combining some textures which are then animated. And first we will see how the professional materials are made in Unreal Engine 4. We can see them in the starter content, and then we will create our own materials and maybe experiment a little bit. I will show you some of the functions. To get us started, let's go to our starter content and select the materials folder. And here we can see different types of materials, and let's open one of them, for example this cobblestone pebble, and it will open a material editor which is built in Unreal Engine 4. So this is a really cool blueprint environment where you can create your own shaders, your own materials to be precise, with this all snippets of code. So it's actually in Unreal Engine the difference between the material and the shader is a little bit blurred, is actually because of this functionality. So we can this code here. Yeah, so these nodes are actually expressions. They are math expressions and color expressions where you can define how your material looks like. So this is like a shader, yeah, but it also applied to the material. So this is our material, this node here, and this is like the shader. This is everything which defines our material to be. So I think we can put it like this. And let's see. This material consists of several parts. As we can see here, each Unreal Engine material have some input nodes. So these input nodes actually are for our different types of textures and different types of math expressions. So, for example, base color, as we can probably guess, is for our color of our material, and as we can see here, it's like a photograph of pebbles. So this is our texture sample, which is our photograph, our texture, which is actually is multiplied by this piece of code, and this piece of code is to create additional levels of detail for our material. For example, if I go back a little bit, I will see this kind of texture applied to it, and I come really close, I can see these details to appear. So these details are different textures which are have different tiling on this particular material. So each time I'm closer and closer to the stones, I'm not actually going into pixels of a texture, because of course textures have a limited resolution to them, and of course we can use 4K textures, but they will use a lot of memory. So we can avoid this by adding different levels of detail and apply textures of a lower resolution to our material, to combine with multiply nodes with our basic texture to give it additional detail when we zoom in. So you can see this is working like this. So this is what this is do. Then we have our metallic properties. Our object is not metallic in any way, it's like stone, so we have it blank here. Specular, which is how it reacts to our light, and as we can see, for the specular we are using our basic texture but multiplied 4 times, as you can see here, and we're feeding this multiply only with the alpha channel of the texture. So each texture have its transparency, and it's fed it into the multiply and then into specular. Roughness is how shiny the object is, and this linear interpolation defines this. We'll talk a little bit about all these functions when we actually work with them. And normal map, as you can see, it's also a texture, and here we have we can define the strengths of this texture, of this normal map, by another texture which is like more of a high map. So to give our texture this 3D effect, as you can see here, this stone over here, it has its side, and as you can see, as I'm rotating the object, my texture shifts a little bit. It's probably not the best solution to create a 3D dimensional effect in a small detail like this, because it's like a flat texture, but with this 3-dimensional effect. I think it's better to use a tessellation object, tessellation properties, and we will talk about this later. So this is how like the finished material look like. Let's add something else. Maybe something more shiny, like this brushed steel. As you can see, it's a little bit more complicated, but just a little bit. We have here our metallic properties, which are put to 1, so it's absolutely metallic. Also we have a roughness, and the roughness is also defined by the texture and some values here. So the roughness, as you can see, is the property of how polished this material is. So this material is really really shiny. It's really not rough, so the roughness is really low on it. Also, we have some micro contrast. So this is like this tiny details which appear when we are closer to the object. When we are farther from the object, they automatically disappear, and as we can see, this different levels of detail. To see how this material works, I will go to my maps folder in starter content and launch the starter map, and we can see all these materials in action here. So where is our cobblestone? So this is our cobblestone, as you can see here. When I'm closing in on it, it's not losing detail, and this three-dimensional function, I guess, is starting to work here. It's a bit stretching the texture, as I see not the best solution here. Let's see, this is our grass, moss, something like this. As you can see, in close I am, the more detail is here, and our metal, burnished steel. Yeah, so this is how it's look like. As you can see, the rough materials are actually automatically reflecting the environment, so these letters are reflected by this metal sphere. So if you want to preview some of the materials and some of the possibilities of the materials, you can preview them in the starter content, which is recommended to have on your first try of Unreal Engine 4. Also, we have here a small scene with the chairs. As you can see, there's some little house here or something, and also some objects and some particles here too, with sounds and so on. Well, so this is how it's look like. Oh, also water. Water is very interesting material. Maybe we can create something like this today. So you don't actually need to model the waves on the surface of the water. You just can use the materials to create this effect. Also, this is a really interesting example when you can see that these colors are changing dynamically, and we also can do this in our material. To check up the material of any object, just select it, and on its properties there will be a material slot, and just click on the magnifying glass over the material asset, and it will drop you with the material. And as you can see here, this is how our material with the glowing animated lights work. And as you can see, we have a time input which actually tells our colors to switch between each other on a sine basis. So this is like a mass expression. Yeah, so this is how the materials look like in general, and we will try to create our own in a second. Yan Chao asks, can I change the color of the material? Sure, of course you can. You can do anything with the material. Let's just create our own right here. Right click, I will right click on my asset browser and select material. As you can see, there's a certain naming convention in Unreal Engine here. You can use any naming convention you want. Actually, you don't need to name things like they did, but it started with M, so it's like for material and then the name. So I'll do the same. I'll create M as material and lesson 2 as the name of our material. So the material is created. To double click it, it will open a blank material editor, and as you can see, let's see what interface we have here. First of all, we have our preview. With left mouse button we can rotate the preview and to see our material in full its glory. Also, we can change the preview object type. So if your object is more like a cylinder or a cube, you can always see how the material looks like in other shapes. But also you can use your own custom mesh. For example, if I go to my meshes in my starter content and select chair, for example, then go back to my material and select sets preview mesh based on the current content browser selection, which is my chair. And as you can see, I can see now this material applied to this chair. So any object you added to the Unreal Engine can actually make it into material editor, and you can preview it here. So but I will stick with the sphere for right now. Also, in your preview, you can switch off the background. As you can see, it's like an HDRI photo, which is standard for Unreal projects. It's really good when you want to preview your reflections on your objects if it's really not rough. But I can switch it off, and the reflections are still there, but there is no that like annoying building in the background. So you can also switch off grid, switch off stats, which are down there. The stats actually shows you how much memory the material takes, and yeah, there is some really complicated materials. In the end, if we will have time, I will show you the material that I was recently creating. It's for the planets generator shader. I'm working on a little side project involving procedural generation of some space objects. And I created a shader which is actually creating planets from scratch, and I can show you this, how this material works. So this really huge material with which generates planets is actually having like 400 instructions, if I'm not if I'm correct. I don't remember right now, but it's definitely more than this. So it depends on your complexity of your project, of your material, of your shader. So the more instructions and mathematical functions you add, the more memory it will use. So also you can here select different filters of our preview as previously in our viewport. You can do the same thing here for this sphere. Also we can switch to different views, which actually I don't know it's really that useful in Material Editor. Also we can show the FPS of our preview. I don't know, where is it? It should be here. And change our camera options. But default options should be alright for basic purposes if you're creating some materials. Then we have details, and this is the important stuff where we can change the detail of every node. So if we add, for example, a multiply node, we can see the details, the properties of this expression. So this is a material expression multiply, so this is this. So multiply is actually like a multiply function. So to really quick explaining this, if I have two numbers, number 2 and number 4, multiplying these numbers will give me 8. So like 4 2 times is 8. So the answer to this, the output of this node will be actually 8. So this is how you can multiply the things here. So you can multiply the colors, you can multiply the textures, but it all works like normal mathematical function. And also it applies to the color, because as to the color, if we create a constant, a constant is like a one number. As you can see, the 0 number means black, the 0.5 means gray, and I'm sorry it's red for me here, but I have a bug. It's a bug of this new version of Unreal Engine 4. where all my gray and black and white stuff represented as red. I don't know why, but it should be 0.5 gray, so like 50% gray, and no 100 but 1. If I select 1, it will be white, but for me it's red. To showcase it, I can plug it into my base color of my material, and as you can see, my material is white now. Again, if I put 0.5, it's like gray, but it's really light gray, so let's put some like 0.2. As you can see, it's a grayish gray material, and if I put 0, it's black. So that's how the numbers work in this material in material editor. So 0 is actually black and 1 is white, and everything in between 0 and 1 is gray, different shades of gray. Okay, so when we select our material node, like the main output node, you can see here that we have different options, and it's divided into different usages. So you can turn on tessellation, you can use translucency, and so on and so forth. It means that these parameters define how this material behaves. So material domain is where our material is used. So this can be a surface like normal for meshes. It can be a decal. Decal is like image which is projected to our geometry. Light function, volume, post-process, it's all attached to the different effects, so we can create some effect functions with our material editor. User interface, which is pretty obvious, it's for the displaying of the UI in our game or project. And virtual texture is actually something like a video or animation from a GIF file which is exported to the Unreal Engine. So the virtual texture is something which is not present in our asset browser, in our content browser, but which is reloading automatically with the code. So for the general purposes and creating materials for the meshes, we're using Surface, of course. Then we have our transparency options, and we have different here. The most common used are translucent and masked, I guess. Opaque is absolute no transparency, so it's for non-transparent objects. Masked is for the objects when we specify the transparency texture. For example, let me find some texture which can explain this. Maybe I really need something black and white. Let's take this one, and I will drop it. I want to drop it in my material editor like this. And to actually make it black and white, I will use the one of the channels. As you can see, each texture consists of 4 channels, 3 for our colors and 1 for our opacity. And I will use only one channel to bring up the black and white image. And as you can see, it's black and white because I use only one channel. If I use, for example, green channel, it's like this. Yeah, and this is what I want actually for my transparency. Yeah, and if we show the whole texture, it looks like this. So we're using the green channel. So if my material is set to masked here, my opacity mask node is actually now active. And I put this, and I put my green channel to the opacity mask. And as you can see now, my material is transparent. The white parts are non-transparent, the black parts are fully transparent. So depends on the texture. So this is the masked version. As you can see, with the masked version you can't actually have a soft transparency. For example, if I put some soft textures here, let me see. Yeah, this works fine. As you can see, this texture has some really grayish parts, like it's soft. So, and if I put this texture into my opacity mask, you can see that mask only works with hard surface. So all this gradients, all this soft passes between the contrast in a texture is actually lost. So it's how the masked transparency works. So, and also it leaves some of the pixels, as you can see here, really rough. So you need to use the mask transparency for a really geometric type objects. But when we use, for example, translucent, we can create more of an opaque effect. So if I put this to opacity, not the opacity mask but the opacity, you can see the transparency is now works with the soft shadows and the soft gradients of my texture. Let's put the green channel, so grayscale channel, and it's the pretty same effect because it's actually black and white. Yeah, so this is how the different types of transparency are working. And as you can see, for the translucent material, we can't use metallic, specular, and roughness. To turn them back, we need go to translucency and change the lighting mode to, let me remember, no, not volume. I think it's forward shading. And then you can see the metallic, specular, and roughness back again. So we can make like glass materials, which are actually shiny and reflecting the surroundings too. We can see this with our material from the starter content, material glass. As you can see here, it's translucent. Yes, with it's surface translucency volume. So yeah, so it's a volume, not forward shading, but volume. And as you can see here, why it's not previewing? As you can see here, it have an opacity and all this basic materials. Oh, so yeah, now it's previewing. So it's in glass, but it also it's transparent material, but it also reflects the stuff. Okay, so this is the basics of our material. There is lots of stuff here, but we will not waste our time here. We will jump right into creating our material, and I will show you how to change the texture, the color, how to change the physical options of the material, and how to create some basic functionality like blinking material, or pulsing material, or animated material. Okay, what did chat have to say? Incha asks, if you have a picture, how do I add the color of the picture? Yeah, this is how the textures are going in, so I will show you just this in a second. So just let's drop some textures here, so we can actually see how it's working. Cobblestones, okay, let's use this. Okay, so to drop a texture, in our material we can, as you can see, I drop just right here, or you can select the texture and then you can add a node. To add a node, you are right clicking on any empty space and you have all these different types of nodes. There's like tons of them here. So if you're searching, actually if you want to add something, you just type in here. So I want to add a texture, so I select, I'm type texture, and as you can see, it filters the nodes which I can add to the texture that I typed. So I can add a texture in object, for example, and as you can see, it's added the texture from our content browser. But if I want to use a node like this, it's a texture sample which have more control. I can just type texture sample, and as you can see, it's over here. I'm creating a texture sample, and it also brings up the texture which is selected in the content browser at the moment. So this is the way to put your textures in Material. To put your textures in Unreal Engine in general, you need to drop it to the folder you want in the content browser, or click import and select an image. I don't think I have one. Maybe I have. Let's go to desktop. Maybe. Yeah, I have something here. For example, this image, and as you can see, it's now a texture in my Unreal Engine. I double clicked it and I'm in a texture editor. As you can see, I have different parameters. I can adjust the brightness of the texture, the coloring, and also I can bring this texture here if I type texture sample. As you can see now, this texture is in my material editor. So this is how you add textures to your material editor. So now let's go through all these nodes we can use. So of course we can use our base color as our color for our material. So as you can see here, why it's so shiny? I don't want it to be so shiny. Yeah, maybe something like this works better. So yeah, I'm connecting this node. To break up a connection, you hold Alt on your keyboard and click on any of the connections, and then you break it. So you connect with your left mouse button, Alt to disconnect. You can also connect, I guess, no. I'm sorry, I forget how to do it. But basically you connect with your left mouse button and you disconnect with Alt. So something like this. So this is going to be our base color. For the metallic, specular and roughness, in general we can use a simple constant number. So to add a constant number, we just right click and type constant. As you can see, there's a 4 types of constant numbers. We like one number, which is 0 at the moment. If I type again constant and select 2 vector, we have a vector of 2 numbers. If I type again constant, it's 3 vector, and now it's a 3 vector, and 3 vector is actually our color, because the first number, the second and the third is actually our R, G and B colors. As you can see, when I double click our 3 numbered constant, we can change the colors now. No, but for me sometimes this works really slow, so I'm trying not to crash my computer. So for example, the constant vector with 3 parameters, the numbers like this representing the color, and we can attach this color to the base color, and now our object is blue. So this is how you colorize your objects. If we have a 2-point vector, as you can see, it's red and green. So red 1, green 0, we have a red color. If we have red 0, green 1, we have a green color. And you can mix and match it, of course. So I have 0.5 and 0.5 for both. We have a yellow color because we're mixing. Half red and half green gives us the yellow color. And for the constant, like one number, it's always black and white, which is my case is red, and I don't know why, but it's actually gray. So yeah, it's gray, but in preview here it's like red. I don't know why. Maybe if I live update it. No, it's just like this. I have to live with this now. And the last one is vector 4, I'm sorry, so it's constant vector 4. And this is the same as the previous one, but the fourth number is actually the transparency. So if we bring it up, double clicking on it, you can see that now we have not only our RGB colors, but we also has a transparency color, so we can use this as a secondary channel. So as you can see here, it's now a transparency thing. So if we use a transparent material like translucent, for example, we can attach it to the opacity. So this is how the basic numbers work. So this is your basic numbers. For the metallic, specular, and roughness, we can use the range from 0 to 1, because for the metallic, specular, and roughness we are working only with black and white to define these features. So let's see how our material will change depending on the different parameters of metallic and specular and roughness. I will use something neutral, maybe some grayish blue here to preview this color. This material, oops, yeah, like this. So it's like a blue sphere. Now let's put metallic in, and we can see how it's working. Let's put specular in, and to put roughness in too. Now we will change these things and see how it affects our material. So also I'm really quickly adding this different stuff, these different parameters here by using my shortcuts on the keyboard. If you hold 1 on the keyboard and press on the empty space, you create a 1 constant number. If you hold 2, you create a vector with 2 numbers. 3, the same thing, 3 numbers. 4, the 4 vector number. So we're creating like this really quickly. Okay, so actually let's delete this, we don't need them. So for now our objects are not metallic, it's not actually reflective at all, it's not reflecting any light. As you can see, it's absolutely I don't know, matte, how you say this, and it's really not rough, so it's like really neutral. So let's crank it up a bit. So let's put metal 1, and as you can see, immediately our material becomes very reflective, but as you can see, it's not actually reflecting any light, it only reflects the surroundings, which are by default this HDRI in our material view. So in our game, in our project, it will be reflecting actually everything around it. So let's turn it off for now. Let's put specular on 1, and now it doesn't show us anything because its material is too rough. So let's put the roughness to 0.5, and as you can see here, now this material is 50% rough, and it's very specular and very metallic. In general, these two parameters, like metallic and specular, are the best used separately. So your material is metallic or it's specular. So if we're creating plastics, for example, it's better to put the metallic on 0, and then as you can see, this reflection of the light in our object is defined by specular. If I put specular to 0.2, as you can see, it's much dimmer. Put it to 1, it will be much brighter. And roughness defines the roughness. So if I put this to 1.5, 0.5, as you can see, it reflects the environment. So this is like a very plastic, polished plastic, glossy plastic. So it's like glossiness parameter. if I put roughness to 1, so the object is super rough, as you can see it's a matte object, so it don't reflect any light or environment. So in this system of of balancing metalness, specularity and roughness is in short called PBR, so it's like PBR material, which translates as physics-based reflections or physics-based material. And you can, of course, depending on what you want to create in your material, you can make like it's more metallic, specular can be 0, and let's put it, I don't know, 0.5 for the roughness. Yeah, so this is our, actually I don't like metallic, I put 0 here and put specularity to 1. Yeah, I like this much better. Metallic materials have the tendency to be a little bit darker on the color, so I want it to be more bright, more like a plastic. Then we have emissive color, and this is why it's called color, because we can plug into emission our 3 vector. So I hold 3 and click on any empty space, and then I can put the emissive color in, and it's now doing nothing because it's black and we can't shine black, so we can create a color for it. Let's go for something opposite to our base color. Let's go, for example, for orange. Yeah, and as you can see now, our object is starting to glow with orange, so it's like a light source now. But as you can see, this emission, this light emission from the object is not very bright. So this is where we can multiply this color and plug it into emissive color to maximize the glow. So let's do this right now. To multiply the color, I obviously need a multiply node. So I can type multiply and it's appear here, yeah, like this. Or I can hold M on my keyboard and press anywhere in the empty space, and I have a multiply node. Now let's see how the mathematical nodes are working. So as you can see, each node has an input, which is on the left side, and output on the left side. Also I can see how my node is receiving colors, so how the node looks like when we put something in the in. So to multiply my color, I need to multiply it by a constant number, so I need to add a constant number here, and then I plug my color to the first and my number to the second. So the A, as you can see, when our mouse is hovering over the node, we can press Ctrl Alt, and there is an extensive description of what this node do, so you can read it. And then we can plug the output node of multiply to our emissive color, and this means that now this color is multiplied by 0. That's why we don't see it at all, because when we multiply something with 0, it yields 0. So that's why our material is not shiny. If we type in our constant 1, so you can see our previous result. So now we multiply this color by 1, which yields this color, because if we multiply anything with 1, we will have this the same result. So to maximize our glow, we need to maximize this number. So let's say 2, and immediately you can see that our material is starting to be more shiny. Let's go crazy and type 50, and as you can see, now it starts glowing like a true light source. And as you can see, the color, which is yellow in this example, is actually the most visible on the rim of this light, not in the center. because this part is so shiny that it's actually going white. Yeah, and so with this you can create a really shiny, glowing materials, which is really cool for some effects. So this is how the emission work, and you can actually multiply everything with everything actually. So let's disconnect our emissive color and let's multiply some basic colors. For example, let's say we have a red color. I can copy that node by Control C, Control F. Oh, I'm sorry, Control C, Control V. And if you want to, for example, combine red and blue, so we put blue in one, so it's now a blue color. And let's multiply them and see what happens. I just can click this one. Think a little bit. Come on. Live notes. Yes, please. Don't want me to show. Okay, just plug in then. We can see on our material. And it's black. Yeah, so it was correct. So it was black. That's because we are multiplying the two colors, but we are multiplying them, how to say it, not additively, because we can multiply, we can combine two colors differently. We can combine them by multiply, or we can combine them by add. And I created this node by holding A on the keyboard and clicking on my empty space here, or you can type add. So add is a plus mathematical function, so it's like 1 plus 1 equals 2. So add is 1 plus one color plus another color yields you the combined color. And let's see how this works. If we put this together, we can see that now it's purple. So let's actually see how this is different. So if we and I can bet you that you were working in the Photoshop. In Photoshop we can combine different colors by adding a screen or multiply effect. They are actually the same as in here. We have multiply is a multiply, and the screen effect is like the add effect, basically. So combining two colors, we can create combined color using add node. So if this is red and this is blue, we have a purple color. If we have, let's say, we have green and blue here, we will have a teal color. So this is if you know the basics of a color, you can pretty easily handle this. But what about our multiply? So the multiply, the best works if we have a contrast image like this one here, and we add some color for it. For example, let's say it's being red. And when we multiply this black and white texture with this color, we will have this texture colored in red. So if I now put this into our base color, you can see that our whites actually colored, or correctly to say multiplied by this red color. So this is how multiply works. So it's actually not just combining like the add function here, or expression, I should call them correctly. This is an expression. It's not combining the two colors like the expression add here, but it's combining them like an overlay in Photoshop. So you're multiplying something with something. I hope this is understandable. And of course, yeah, we can choose whatever color we want. So some blue. It can be blue. Yeah, so now it's a blue color. Yeah, and with this we can create some pretty interesting results. Also, we can apply this to some other texture, not black and white. And as you can see, now this texture is colored with this color. So this is how multiplying the textures and the color work. So this is like the basic thing. Also, we can use this, for example, black and white texture to add some emission for our project. For example, as you can see, now we're multiplying our color with the number 50 to gain this strong lighting. But also we can use the texture for our emission, for example, and as you can see now our texture is emitting color. Of course it works like a mask, so the whites will be actually emission and the black ones will be none. So as you can see here, the font here is actually shiny, and we can maximize this effect by plugging our texture sample to the multiply node, and then to the number, and then to the emissive color. And this means that our letters are now more shiny by 50. We can go further and add another functionality here. We can add another multiply before our multiplying. As you can see, this multiply node gives us the same texture, but the whites are colored in yellow, and then we multiply this yellow color with by 50, and we have a yellow shining thingy, Unreal Engine logo. Yeah, so you can do a lot of cool stuff with Unreal Engine. And the last thing I want to show you with the colors is actually the masking. And we have a really good examples here of the different masks. Let's find something really simple. Let's see. You can, by the way, create these masks by yourself in Photoshop, for example. What we have here, no, it's not that good. Cancel. No, I don't want this. Let's take what about this one? Yeah, this might work. Okay, so let's it's selected here, so I can just type texture sample. And I will show you in a second how it's we can do this, but first I will show you this in how it's actually done. Let's see, where is the material for our, yeah, it's here, material chair. And as you can see here, this mask is used to apply different colors to the different parts of the image. So we have like colors, masks, and a lot of multiplying stuff. Yeah. Now let's see how it works. No, let's do it a little bit another way. Let's turn off our emission color and our base color, and let's create masks by mask by ourselves, but with two colors only. So we have our black and white image, right? We will use this image to create a two-color mask. So we will paint the blacks with one color and the whites with another color and then use it as a mask to display different textures. So let's do this. We will not use this, we will use the colors. So first of all, we will multiply our whites with a color. Let it be green. Or no, we'll not multiply it. We will use the lerp. Yes, actually, it will be a good idea. Yes. So I have a texture which will work as our mask. We will have two colors, and we will add a lerp node. So lerp is short for linear interpolate. And what this node does, it takes two inputs. It can be textures, it can be colors, so it can be two colors, and then we can add a mask in the alpha section here to create the mask for these two inputs. For example, our green will be A, our red will be B, and the black and white mask, which is our texture, will be in alpha. And if I attach this to base color, you can see that now the whites, which are the B, are red, and the green, which is the blacks, and the A is everything else. Okay, so we have like we can split the colors by this black and white mask, so this black and white alpha channel. Now we will use these colors to apply different textures. For example, I want my reds to be for example gold, so let's use gold texture. Where's our textures? Gold, 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 metal gold, and I cannot drop them, I don't know why, so I will choose like this. So our reds will be gold and our greens will be like this rock, for example, to actually see the difference. Okay, and to do this, you know what? To do this, we don't actually need the colors. I wanted to show you so badly the colors blending with the different RGB channels, but actually don't need them because we actually can put it right here and it will work. Yeah, and that's it. I will create a texture maybe next time to show you how this stuff works. Custom texture, because I can't find the texture with the plain colors here. This is the base shown with the plain colors. Yeah, but this is how you can do this. You can with a linear interpolate node, you can combine the colors, combine the textures into different things, different combined textures with a mask, black and white mask. You can also do this with the RGB mask, which is a little bit more flexible, but I just don't see a good texture here for this. So yeah. Okay, and we have this emission node. We can still plug it in, but it's not multiplied by anything, so we can add another texture. Let's take this one. I'm also forgetting just it can't be dragged, so to do it like this. And yeah, our green channel can be our alpha channel, so and you can see it's something like this. Okay, so a little bit messy and a little bit all over the place for the first tutorial on materials, but it's the very basics. So you can see you can make a pretty cool results. The last thing I will show you today for this is the texture coordinates. If we type texture coordinate, we can have it here. It actually helps you to tile your texture to tile your texture on your material. And to do this, we can switch this texture chord to our UV's input in our texture sample. So it's like the basic UV tiling. So if I put this 2 and 2 in properties, you can see that our texture is now more dense, because our texture is actually seamless. So we can do it indefinitely, and this grid will be more and more dense. So I can put 1 here, for example, and it will stretch this texture. Yeah, so I can do the same thing for our V tiling. It's vertical, and as you can see now, it's stretched up vertically. Yeah, so if we put like something like 0.5 here, you can see that now this texture is really big and it has seams. So something like this. So you can add additional control over your textures, and also you can see it in the preview. In the preview, you can see the scale of the texture you are applying. Yeah. So let's turn it off now. Yeah. So this is how the basics of the material work. So the most important nodes which we learned today are actually multiply, which is multiplying our input, add, which actually sums the two inputs together, and the lerp, which combines two inputs with an alpha input. You also can remember that you should remember rather that this alpha can be a constant, so it can be a number. If I combining two textures without material, without transparency, black and white texture, you can see it combines 50-50, so it's 50% this texture and 50% this texture. If I change it to 1, it will be only the I will just preview this. Yeah, it will only be the B texture. Yeah, it's only the B texture. If I put it 0, it will be only the A texture, as you can see here. Yeah, so you can do it with a constant, or you can do it with your black and white texture, which works the same. And for yeah, so let's finish for today. It was a little bit messy. I'm sorry for this. It's a little bit all over the place. I will show you more about this RGB mixing texture stuff in the next lesson. And for now, I will answer some of your questions on the chat if there's any. And also, I will show you this like super intense shader that I was creating recently, to show you how this how far you can push the material shaders. Okay, what have we here? If I have a picture, how do I add the color to the picture? We already talked about this. Would this material actually illuminate other objects? Yes, the answer is yes, it will illuminate other objects. You can't use it as a effective light source like with casting shadows and stuff, but it can illuminate the environment. Okay, so what we have here is a planet, and the whole thing was created only with materials and shaders, and the purpose, the end goal of this project is to create like procedural generation. So you don't have to input anything. The planets will be generated by themselves. And with the most important stuff is the difference between them. So if I created already some samples, so you can put some different samples on it and see how this is the same material, but with the same material you can create like this kind of planet, or this kind of planet, or this kind of planet. So, and it looks like, in the material editor, it looks like this. So yeah, it's pretty big, and everything that you can see is like a material, plus it's not using any textures. It's only using noise generator, which is built into material editor. So it's generating some random noise patterns, and then these random noise patterns are changed to create this planets thing. So there's a lot of stuff here. As you can see, you can comment and add like this colorful blocks to define which part of the material do what. So it's like, this is for the climate zones, this is for the forests, this is for the clouds, this is for the atmosphere and stuff. So yeah, this is like looks like this, and then you can actually a little bit clean it up. I'm like in the middle of this right now, where you can collapse some of this part of your code into a function. For example, I'm using the same piece of code everywhere in this material blueprint. For example, this part is repeating here, 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 and in most of the cases, and I can collapse it to a very neatly created function which looked like this. So for example, I collapsed all the code into one function, and only I need to do is to add some inputs to it. So as you can see, the material is the same, but there's a much less space actually used, so it's more clean. And if I double click on the function, boom, and I'm in the function itself. So this is the function which for example creates the atmosphere of the planet. So it's collapsed into this, and in the material itself it's represented like this. And the most important stuff about these materials is actually the thing that you can edit them real time. So it's called the material instance, and the material instances actually create the copy of the material, and you can, in your material editor, you can expose the parameters. For example, in my material here, these parameters are exposed. They're constants, so they're like one number, but they are now a parameter. So that means that I can access them in this list. So, for example, I can change the material of this planet on the fly using the parameters that I expose. For example, I can change the color of the atmosphere, like here. Atmosphere actually uses two colors, one for the sunset, where the sun sets on the edge of the planet, so I can change that color too. I can make it brighter, I can make it I don't know, more dense, for example. It's important for planet. I can make change the brightness for the different parts, for the dark side and for the light side. I can change the texture. If I want, I can remove the atmosphere altogether and create a dead planet, for example. To do this, I just need to remove the brightness to 0 for everyone. For example, I can change the amount of water on the planet, so with one slider, and as you can see now there is no water, and I can remove the rivers too. I all categorize them in different categories like vegetation, snow, and so on, clouds, mountains. So every feature which is needed in your material can be categorized into different stuff. Yeah, I'm thinking about adding this material to the Unreal Engine marketplace for free. So when it will be fully ready, I think you can upload it if you want it. Just to see how crazy materials can be. Yeah. So, and of course you can edit the color of everything on the planet. So it's like the purpose of it, just to go crazy. Yeah, so this is how far you can push all this stuff, and then you can test it. Let's put back just some atmosphere for the wow effect, and then you can test it, and it will all work in the game. As you can see, now we are having the same planet we created a second ago underneath our spaceship or something. So this is like the live example of how far you can push the materials in your project. So it's really cool to mess around with this. I also suggest you to check out the official Unreal tutorials for the material section. They're really in depth, and you can find all the information you need there. Next time we will go with more materials. We can create. I will show you the masking by the channel color. We'll talk about component masks and other stuff, and animated materials too, so we can animate our colors and our textures. Yeah, so this is it. Thank you very much. If you have any questions, put them on Discord, and see you next time. Bye.